This is not difficult, but there's no Googling. Sorry?
I said, you say it's not difficult.
But.
You've already done it.
I was putting the but. There's no Googling here. You really have to know what's going on. Okay. Let's see how far we get. And we might have to redo some of our plans based on how fast we go. And I don't mean to go faster than we need to. But, okay, so what are we doing? We are replicating objects. And for replication, we have the sync system. And the sync system has a client and a server. And the sync server is like RMI++, RMI registry++. It keeps track of the serialized state of an object, and it also merges asynchronous, concurrently modified objects. And the client is the one that listens to local changes and sends things to the server. So here we see it's name server plus structure-based collaboration functions. Okay, so we saw the notion of logical structure last time based on properties and certain other patterns in the interface. So it offers functions based on that structure. Okay, and it understands basically three types of structures: records, which are sort of properties, collections of properties, vectors, and hash table. And the client buffers changes also, so that they can be sent to the server, and it allows flexibility, so you can synchronize on each event. Okay, so as soon as the client receives the event, it just forwards it to the server, and it does that if the real-time synchronized property in the sync client is true. Otherwise, you have to call synchronize method in it repeatedly to synchronize. Okay, so it's trying to do both games and Dropbox in sort of one framework. It actually was invented to be Dropbox of objects. I just used it in this fashion. It is not meant to, you guys will see in your performance how worse it is than RMI. But it's not noticeably worse if the network is fast enough. And you have a little UI also to go and set the mode. Okay, so you can interactively set it on and off. There's a UI that comes with the system. So in terms of model view controller, the sync client looks like both a view and a controller, and it sends changes remotely. Okay. So it sends these notifications, and it invokes write methods. So because it receives notifications and also sends them, it's like a view. Because it invokes write methods, it's like a controller. Okay, and if you don't believe me that that's what a model view controller is, you guys have a reference. And I will also send you guys a reference on how that model view controller paradigm got gradually corrupted, if you will, and how the web terminology is different. Just because web doesn't have the notion of callbacks, it's based on this polling mode, and because of the polling mode, things just changed. Okay, and that was the difference. So I meant to send you guys that thumb, but I'll send it. I don't remember now. Okay, so the sync client doesn't have to and doesn't call read methods. It just sends the notifications it receives from the write methods, and then the read state is supposed to be derived by the object from the editable state. Okay, and the initial state is the physical state, the physical structure that we get from serialization. So that's a little confusion here, just because Java does that's the way Java does it, and that state is then kept in sync through these notifications. So that's a basic structure. Okay, and this is, let's start looking at code, and let's just go and see how we might want to change this basic structure. So we saw the code earlier, and we were notifying events. And I have this thing about transparency versus customization. So how aware is this model of the fact that it is replicated? Now, which parts of it are there because sync is going to deal with it?
Well, that's because there's one property that's transient, and then it's marked serializable.
So it's marked as serializable, and sync cannot deal with it if it's not serializable. And of course, when you mark it as serializable, you've got to do the transient business, which is easier said than done. I spent a lot of time dealing with the model that Bo had. And then what other things, so that those blue things are the ones that sync uses, but can you argue that these things should exist anyway? If I want to just send the object across, not replicate it, I still need to do all this stuff.
Serializable and the property change stuff is probably common.
It's standard. So I'm using standard stuff. So, you can argue that this is a really practical, useful system, and it's allowing you to have total transparency. Okay, as long as you meet certain guidelines. Okay? So these things are also there that sync uses, but you can argue this is just stuff you should have. Okay? So you win along one dimension. I mean, you can never win, by the way, in systems. Right? So where am I losing, perhaps?
The implementation of sync is probably pretty, or the API might be pretty complicated.
But what, okay.
Your model's pretty simple.
Okay, so that's a good point. Somewhere you've got to, people, when they get ankle injury, when they get knee injuries, they all put this knee pads, knee braces. And I never put knee braces. Why don't I put knee braces? Sorry? Oh, I hurt my knee. I just take off. Because some other part will have to take the brunt, right? And that's exactly the point you're making. I just thought of the analogy as you said it, okay? Because, it's standard. All my problems occurred because in Austria and Venice, I walked way too much and I hurt my right foot. And then my left knee went, and then my, I was compensating everywhere. And somewhere the pressure was going, and my whole body collapsed as a result. Okay, so it's a miracle I'm here giving lectures. So yes. So maybe somewhere else we'll have to give. That's if we are flexible, or maybe so let's think of something. So where do I lose? Maybe that's a good general principle. That when I'm going to have all this transparency in one place, either I will not have flexibility or have flexibility in some other place. Think about all the reasons why, what replication was. One of the things we said replicated systems allow us to do, one kind of flexibility that they allow, that shared memory didn't allow, that replicated memory didn't allow. Do you guys remember what that was? Every assignment, if I went and replicated it, to be expensive, and in terms of what the user wants, the word you used at one time, transactions.
They probably want some kind of transactional semantics.
Some kind of flexibility that, not this thing and not now. Not now we get. And that's where we get with the set real-time synchronize. And that is where, because the model is unaware, your sync system had to have that little call there. Okay? But what about what is shared? Supposing I don't want certain parts shared. What would I do here? And by the way, in your project, you have to do something like that. You'll ultimately, when you do your project, you will make that command string, you will not make it shareable.
No property change.
Okay, so you don't send the property change notification. And anything else that might break. Now I said, hey, property change notification is not meant for sync. So if you don't send that notification, something else could go wrong.
You have something else, like you have a local client that wants to see, that needs that information, like say display a view or something.
This view, the user won't see it. The local user will make that change and won't see it. Okay.
Overloaded use notification.
So there we go. I said, you win, you lose. Okay, and what's the general principle, by the way, in this winning, losing? That you want the automation, you want flexibility. Have you guys learned of a principle in systems design that says, how to get both?
Right, two systems.
Write two systems? No, I want to write one system. Make the common case easy. Make the uncommon case possible, but not necessarily easy. Okay. So the common case is that we're sharing everything. The uncommon case is that I'll go and share something selectively. So I'll hack that perhaps. Okay. And what might we do, guys? I mean, just become API designers. So I could have two kinds of notifications also, right? I could have sync listening to one kind. I could have the model just use two things, remote, and I've thought about that actually. Remote notifications and local notifications. But anything else you guys can think of?
The only thing I can think of is instead of those two fire property changes, you double up on that and have some kind of identifier to say.
But that's what I was saying, like just have two property change
I
supports.
thought you meant like a custom implement.
Okay, so that's the other thing. We have two property chain supports, and guys listening to different ones. Anything else? I mean, think of his principle. Maybe we don't change the model. We'll go and change some other part of the system. And then the answer becomes a little easier.
What's the second argument for the fire property change that's null in both of those examples? What's it?
So you said, right, that the view could listen to it also.
Oh, no. What is actually the second argument in the...
Second argument, I'm sorry. Argument is overloaded here. It's the old value.
Oh.
But, it could fire something. You're saying just have some extra field in there that can be tested. I really don't mean that. Yeah, we all used to that, right? I mean, this is how we deal with constraints. I mean, programming is about living with APIs. And then it becomes like a puzzle. How do I go and use existing things? So, can decide which objects are replicated and when they are replicated. We'd like that to happen. But, you'd have to go and customize the property notifications, which also go to local observers. And then the end user can't control it. Okay, so we would want the end user to also have a nice user interface to go and say, okay, I want the shared now, I don't want the shared now, perhaps. So we'd like some other part of the system. So the replication system can provide an API that allows this to happen. Just say, don't replicate this property. It's easy. It listens to the events and just doesn't forward. Okay? And it can even provide the end user with the UI to go and change these properties, okay, which is kind of what we saw. So now we get to sort of the real API, which is, again, now we are getting away from concepts, but closer to your assignment. I mean, you need to work with an API. So where you had in RMI, all these static classes, you also have many static classes in here. I've tried to combine them into one big static class, sync. Okay? And where you had register, you have replicate. Where you had lookup, you have still lookup. Okay? And the only fundamental difference, not even fundamental, but only slight difference between register and replicate is that register takes the port number, and to me port numbers are not that meaningful. So to me a string would be good, and it would be nice if the system automatically goes and finds the next available port number and binds it to the string. So, and also you would need some kind of awareness also, so you give a little ID along with the replicate, and that is the ID you use also for the client here. Okay. You have an ID for the object, of course, but even for the client sync client, you have an ID. Okay, and you get back a sync client object from this. Okay, and the sync client object you could use for other things, and then so that's the how do you, so and here the owner. Let's say assume that some program is registering the object, and the other guys are going to replicate it or look it up. Okay, so the owner goes and calls replicate, and the lookup guy calls lookup, just like RMI. Okay, and that's the clients. The server, just as you have RMI, the way to start the RMI registry, you have a way to start the sync server, and there's a main method in the sync server that you can execute directly. Or from another program, you can just call that main method by saying instantiate this object, and it takes certain arguments, and that's how you start the sync server. Okay, so that's the top level view. Any questions so far about the arguments? Okay, you'll see them being used. Okay, so again, conceptually, we are replicating rather than registering. Okay. Okay, and notice we got back from replicate a sync client object. Okay, so sync client is an object, and from sync client we can get back an object that represents our connection to the server. Okay, that's our server proxy. So we might want to go and say, So why do I have sync line? Why do I have multiple sync lines in a system? I might be involved, I might have, so do you want to suggest something? Why might a program have multiple sync lines?
They might have multiple objects.
So with the sync line, we can register many objects. I mean, we can register, actually, I get back a default sync line here. It's just a little confusing. But I can actually create a sync line first, and then through it, this is what's really happening. I create a sync line, and then I go and say, please replicate this object. Okay, so I just combine these two things into one. But the basic point is that I might have many sessions, and I might have many roles. Okay, so I can have a sync line for each role. Okay, so I can be professor, and I can be an employee. The two classic kind of roles. So I guess professor is an employee. I can be a sportsman. Okay, so I have both of these two things. So I can talk. I can have a session on ankle injuries, and I can have a session on teaching and how to teaching. So the idea is that you can have multiple sync lines, and each sync client can connect to multiple servers. Okay, I can have a PowerPoint session going here. I might have a game going here. I might have other things going here. So you have all this flexibility. In fact, you can have multiple sync servers in an application process. An application process can have multiple sync clients. Each sync client can talk to multiple servers. When you design a system like this, you want to make it as flexible as possible, as you can imagine. And that's what we did. Okay? So you get back, when you do replicate, you get back a new sync client which registers that, but you can also create a sync client separate. Okay? So that's what's happening here. I get a sync client. From sync client, I get my connection to the server, and then I can say, send these messages to your, hey client, send messages to this server either immediately or when I want to. And that is where this real-time synchronized property comes in, and the synchronized method comes in. Okay? So you've got these levels of interaction. Okay? And this is the UI for that. So a sync client can connect to multiple servers, one for a session. And now let's just look at code. I'm starting my sync server, and I'm saying instantiate yourself. That's what I really want to say. And I've added a few extra arguments. I'm saying, okay, this is your ID on this machine. Okay, so just as you would give a port number, I just say this is your ID. A, B, C, D, E, F, whatever. Okay, and I'm calling it A. Okay, and the minus UI would mean, please visualize what you're doing to the user. Okay. And here's a little detail, guys, that you have to know. If you just run it from the Eclipse, it won't work. You have to go and set a Java security policy file here. Okay, but make sure this Java policy file is in your system. Okay, otherwise you'll get access violations. And I don't completely understand this. I at one time understood it, but I tried to Google and I couldn't find information. I tried not to give the security policy, and it fails again. Okay, so you have to go and set the security policy to allow clients to connect to it. And there is a sync interval also you have to specify. You had to specify it many years ago. So I have some things here. So this opens the access. And the sync server is something that's saving state in files. And there is some interval that is the maximum time that should elapse, number of bytes, maximum number of bytes that you should accumulate before writing. Or it's something to do with that. Okay? And there is some bug in Java, or there was some bug in Java, that if you didn't set this value to too high, you'd get the server failing. Okay? So I tried to Google again for this, and it said it has to do with the bug. So I'm not sure you really need it, but it doesn't harm to go and put these as VM arguments, okay? Not as Java arguments. This is what you give to the VM. Okay? And this is the policy file that you have to give. Well, you can probably have better permission for things, but this just says all permissions. Okay? Okay, so that's the server. That's easy. The client is also not too hard. So I go and construct the name of the server, localhost I'm doing, plus my ID. Okay. I give a name to my model, okay, just as you would do with register. I give myself a name, and that name is going to be known to the system, and that's going to be used for all kinds of awareness. Okay, so I say my name is Alice. And what happened historically, this was in the mid-90s, early 90s. I had like about 12 RAs at that time, and they were all doing various things. And one of them was doing sync, and one of them was doing object editor, and they weren't talking to each other, so it was not like one person doing these things. So OE, the object editor tool, didn't exist when this was being built. Okay? Later, when object editor got built, I went and created an object editor user interface to sync also. Okay? Because that was a test for object editor. So this says, please give me the OE interface. Okay, this is something I added on top. UI just meant, the original sync UI. So you'll see that the UI has there's mismatched UI. Okay, one is object editor, automatic, one is the other one. But the nice thing with object editor is that as sync changed, I could keep getting the UI to change also because it's automatic. And that was a real benefit. Okay? So this is just saying, please use the OE user interface. And I say server name, model name. I give the model. I give my ID. I give sync ARGS, which says give me the OE UI. And you see here I get the server proxy. So server name, I get the server proxy for that. And then the server proxy is an editable object. So I can actually go and say, object editor, please edit the server proxy or my connection with the server. And what I really get is a UI. I'll just show you. Okay. So this is a replicated object, takes place of port ID. This is for session management. I can just say I'm Alice versus Bob. And this is the client side UI with the OE option. And there are two UIs you'll see. One is sort of what objects have been registered, and one UI allows me to control what happens to these objects. Okay? So when I go and say this OE, this is just the browser you'll get, and this is where you actually have controls. Okay, and let's just see the pictures. So this is the server UI. It just tells me that this is one object in the repository. Okay, this would be nice with RMI also, right? RMI registry to see what objects there are in RMI. You get to see what objects are in the server. Okay, and for debugging purposes, trust me, this is very useful. Okay. This is my two UIs, my three windows that come up. This is my browser UI. Okay, this is the -OE option. Okay, I get to see what objects I have registered. Okay, I get to see who else is there in my session. Nobody else in my session. I get to see some other things. What's the address, what's my name, and so forth. That's my state, replicated state. Okay? This is my object that I've registered. Okay? So I said object editor.edit this object, so that's what got registered. And this is my controls. Okay, so I said object editor.edit server proxy. This is my proxy, and it says, do you want to do real-time synchronize or not synchronize? And if not, goodbye. Okay? So you will see this UI. I mean, it's again, nothing conceptually difficult here, except that it's not on the web. Okay, and this is practical stuff you need to deal with. Okay. So that was Alice. She was the owner. This is Bob. He also wants the OE UI, and he's not going to have any controls, so he just says edit model. And he does a lookup, and from the lookup he gets back a model that he goes and edits. Okay? He still gets the browser UI. Okay? So not very, very different. And you get the browser UI, no controls, and you get your UI to change things. And you get to see that this object is in your local, So imagine in Dropbox, you had this, you see objects in the web, and you see objects on your desktop, right, on your drive. So the server is what's on the web, and what's here is on your drive, essentially. Think of it that way. Okay, this is the replicated objects that I have replicated, and that has got all the objects that are replicated. And this tells you also which other clients are involved in this, are sharing my replicas. Okay, so each server defines essentially a session. So who else is in my session? If you want. Okay. And after Bob does the lookup, and after Bob registers something, Alice gets to see that there's another participant in the session. Okay, so saying that this object is being shared by these many people. Okay, so again, this is nice visually to see who all are sharing my object. Okay? Questions? Okay. So basically, this is something I've said earlier. I had this slide, I didn't delete it because this is important, and no harm repeating it. Okay, now let's get to the issue of software engineering. So if you notice, Alice used a call called replicate, okay, which is like your register. Bob used a call called lookup, which is like your lookup. Now if you're creating a game, if you're creating Dropbox, that's okay. Okay, I registered my object, I'm the owner, I set the access rights, you're the guy who's looking up, you're joining the session, and that's how Dropbox works, right? I advertise a folder and you join it, I do one operation, you do another operation. Fair enough. This is what Sync was designed for. But like I said, I try to use it for all kinds of other things later also. If you're doing a game, is this the API? Do you see a problem with this API? When we said in games also you have you have these replicas. Is there a distinction between the owner and other people? I don't know. There might be. Sometimes there is. Sometimes, I mean, you want to run the same program, really.
Bob needs to know if there's a game already in progress.
Bob needs to know if there's a game in progress or not, and then we can run it into race conditions. They both decide to start this thing again at the same time. So what we'd like to do, so the lack of symmetry is okay in these asynchronous data sharing things, if you will, okay? But race conditions in synchronous sessions, and you would really like to run the same program at both ends. So then the question becomes, how do I integrate these two calls? Now we have to put a software engineering hat on.
Register return what you just registered for was already in the code.
So you want register or lookup?
Everybody uses register.
Yes.
And you get back what's already there if there is some.
Otherwise?
It registers it and gives it back to you anyway.
So I should call it basically replicate or lookup, right? If there's already something and I'm giving it a name, right? In both cases, I'm giving a name. So I say replicate or register or lookup, whichever is the case. If I'm the first guy, replicate. If I'm not the first guy, lookup. But what do I send instead of the, where's the register, replicate, yeah. What do I send instead of the model? I mean, right, if there's, I've given it a name, but what should I give for the model? How did I get the model? Okay. So could I just give it the class? Okay. Let the system instantiate. It has my whole class path. You know, my server has all of my complete class path. So it can instantiate that. It can say in Java, new instance. Actually, I didn't show you that earlier, but those two things. So this is what I would do now. I would just, rather than sending a model, I would say console expense class. Okay, I would go and send this class name, and it would go and instantiate. Okay. Now, one little detail, then I get back not a sync line, but I get back a model, an object. So I can't go and say sync client, get server proxy, do that. So, there's sync instantiates, systems instantiates if replicate, if the object doesn't exist. And now I have, by the way, I'm not saying Alice or Bob. Alice and Bob are coming. As you guys, I saw your demos. You did a very good job. That you would just take an argument from the user. So from the user, you just get Alice or Bob from this passage. Okay? So we have one program being written. Okay, so that's. But I can't access sync client. So what I would do is I have another call which is sync client, which is basically I have replicator lookup, which is simpler to imagine. But this is the more complicated call, which is again replicate, except that it takes the class name rather than a class rather than an object. Okay, I get back a sync client, and from sync client I can do all the other things. Okay, so you'll see me use both. That replicate or register lookup is an easier call to deal with, so you see that a lot. But this is what you'll be doing most probably. That I get back server proxy, and then I can do all the fun stuff I was doing. Oh yeah, from the server proxy I can say, please give me the model. So I need to, in the previous replicate I passed it the model, so I didn't need the model back. Now I might get the model back. So I just go and tell the sync client. That's what the previous picture was showing. I didn't highlight that. I have a call that says, give me the model, and here's the model name, and I get back the model. Okay, and either I've just created a new model or I got back. Okay. Now you guys are armed completely to do your assignment. Okay, but you've got the basic call here. Okay. Okay. Get client as in previous replicate. Sorry, I made these changes just before the class. And get model from client. Okay, this is too easy to work perfectly. So what if my constructor for concert expense took arguments?
Require that you have a no argument constructor.
Absolutely. Is that a programming idea? Have init methods?
Good enough for Java Beans. I'm sure it's good enough for Sync.
Actually, good enough for Smalltalk. Smalltalk never had constructors.
Really?
Constructors got invented by C++. So they just had init methods. And now the thinking is that one should just have init methods anyway. You have much more flexibility with init methods than you have with constructors. But we won't get into that. We'll just say, hey, init methods exist. So we will just go and do init after the class. Okay, so we can require the constructor to have no arguments and do init afterwards.
But if you don't know if it was replicated, like you got back an instance of a replicated object, or it was created for you, could you essentially wipe out data with that?
Couldn't you wipe out data with that? Too good to be true.
I mean, I guess you could have a flag saying, like, was it made called and dropped it?
Yeah, so we're making it more aware and getting messy, right? So this is the problem. It's being executed at each site. Wasting, even if there was no problem, you're just wasting the resources. And it may not exist, it may not be idempotent, even if we are starting from initial state. Init twice, init might print a check. And you're printing the check multiple times, once for each replica. It might send an email. It might go and open a Google spreadsheet. Okay? Create a Google spreadsheet. You're creating multiple Google spreadsheets. Okay? So this solution is not working. So what should we do? Software engineering hack, guys. This is.
You probably should have, like, maybe an object array or something passed into your replicator lookup, which you need to make your object. But that would mean every program needs to be aware of what the initial state should be.
That's an interesting idea. That you just send one object and say, if this is the first one, just use this as an object.
Or you could provide the arguments for that creation.
No, but I like your solution the better. Just create the object. Of course, if you're creating a big game, everybody's creating that game then. But that's an interesting idea. I didn't think of that one. Okay,
Yeah,
but
pass the class name, an object array.
The class name, oh, as an object array. So I misinterpreted you, you know?
You can do both.
Yeah. Just
Yeah,
pass.
I'm saying if you've got that object array and you've got the class name and all the clients have all this code, then you could just send that and everyone would just say, oh, I'll create.
No. The trouble is that we can't, the object has to be created beforehand, okay? Either you create the object beforehand or you let the server create the object. One of these two things, okay? Because otherwise you don't know that you're going to raise conditions. So either you created the object and you say, okay, you take my object or his object, whichever object comes first. And then we'll return back the winning object. Okay? Either you do that, or you tell the sync system to instantiate, in which case you could pass the name of the class, plus you could pass an array of parameters, which is what you're saying, right?
Or you could create the object locally and say if it doesn't exist.
That's the other, right? Right. So I like that. I haven't thought of that ramifications completely. So let's just, that's a good idea, but let's talk about taking a bad idea, making it better. Take a sad song and make it better. So we'll go and take this. So we have the server instantiate. We don't want every guy to instantiate the object. It may be expensive. It may be all kinds of, the object instantiated in this constructor. It might go and, open up Google spreadsheet. So probably there's side effects of creating multiple instances of that object. Okay. So let's assume that that's going to be an issue. So you're saying otherwise you pass to the object an array of the thing, and then it does a reflection and it sees, which constructor exists and pass those parameters.
Or you could provide the constructor to take in that array and you know what order the array is going to. But that's messed up.
If I could put what in the array?
In the array, you could put your arguments.
Yeah.
And have a constructor which accepts the array with the proper.
Okay, so have the constructor. So then you program with an array, and the trouble with that is that the user could go and pass it 0 elements or 1 element or 5 elements or 10 elements.
It's a little bit of trouble. But
Yeah. Any other elegant solution that you can think of? Something that you have learned in software engineering, one of the first patterns you learned.
Creational pattern.
Right.
It's going to go with factory.
And you think that'll work here?
I don't know, but it's the creational pattern. I know.
System knows.
Here's the problem.
System knows if object should be instantiated, right? The application knows how to instantiate. Can't you just pass the how-to to the system? And the system decides whether to use the how-to or not? And you would, in functional programming, basically pass a procedure to instantiate. Java doesn't have, methods being called directly, but, it's not such a big problem, though Josh thinks it is. And he uses Scala instead, which is some functional extension that allows functions to be passed, but otherwise you can just pass an object with a function. And you pass the function. And that's what a factory is. Okay, instantiating procedure simply embedded in an object. So this is the function you're passing. You put that in an object because you can't pass functions. And we can allow a factory to be used among multiple classes. So allow the new instance to take the class as a parameter, just in case it's going to do something, for a family of classes. And that's it. So, this factory idea is good many places, and often you're surprised because you didn't think of using it, and in retrospect it's easy. Okay. So now I have this interface. I can create a console expense factory, and I can say a console expense with 15 points.
Isn't it usually bad practice to do something like this though? Because this kind of clutters everything. Because you have basically a factory that's only ever going to be used once. Think about it.
Not necessarily. I can have this session of console expenses and this session of console expenses. Okay. But, a factory could be used to create a singleton. You compose two patterns together for which, singleton, he loves singleton, he loves,
We can have an abstract singleton factory if we want. We can go all the way.
So, we'll just use this. Okay. And I can't tell you, like everybody else, I'm lazy. I don't want to create factories, and I don't want to create interfaces, even though I tell people to do it. And every time I don't create an interface and I don't create a factory, I curse myself, and I say, oh, I can't listen to myself, And so, you just get so many benefits from having factories. Okay. And you will we don't pass a factory quiet. What we'll do is say, council expenditure class, I can pass it, I can go and register with the system and say, whenever this class is instantiated, please use this particular factory. Okay? Then I can use this factory for multiple kinds of classes rather than one class and for multiple instantiations. So I don't go and pass a factory each time. I use the same call and I just added this veneer on top.
So then the factory is aware of the initial conditions of each.
Yeah. So for each constructor parameters, you create a separate factory. Absolutely. That's what factories do. Okay. And here programmer binds class to factory instance, and system invokes method and factory to instantiate. And you're creating a single factory for all classes, and you can do this for multiple things. So by the way, this is just a detail. I don't know whether you'll ever need this, but I can go and pass a list of model names, a list of class names, and then go and register a factory for all of them, and you get like a list of objects. So this is just showing you that the same factory could be used for instantiating multiple times. Okay, nothing great here. Okay, you get back a list of models. You can atomically create a bunch of objects at the same time. Okay, the system sync is pretty practical, and I did a lot of things to make it practical. It has been used actually for a thesis. Did I tell you guys? Yeah, I think I told you that. So I really had to make sure when that was being used for that. It was used in a study, and I had to really make sure that I had the practical thing. Okay. So this is just showing you how multiple objects can be created. Okay, now let's get to some interesting things. Okay. So we have talked about the what of sharing. Okay, we talked about making things symmetric. Let's now talk about the when of sharing. Okay, of course you can share it at real time, so that's not an issue. Let's now talk about asynchronous sharing, which is more complicated than synchronous sharing actually. Even though it doesn't have performance issues, the divergence can be more in asynchronous collaboration. Okay, so let's say I am saying real-time synchronized, and my partner is saying not real-time synchronized. What might that mean actually?
Maybe you're interested in, if when you push an update, you want everyone to get it at the same time, but maybe your partner is like, well, I'm sort of dilly-dallying a bit. I'm not quite sure what I want, so I'll just wait and have a transaction whenever I want, whenever I'm happy with my values.
I'm saying I don't want to send things immediately. He says I'll send things immediately. Okay, now you can have a little button saying I don't want to receive things immediately also. Okay, and I think there is a sync that feature too. But for now, I'll receive whatever somebody sends me, but I'll send only when I want. Okay. So I go and change from 0 to 8. I hit return. Okay. My local value becomes 188, which means my local model view controller all talk to each other, and I'm seeing, I've changed 8, I've changed ticket price, I've got 188. My collaborator knows nothing because I have not pressed synchronize. But my local view and controller know it. Okay, this is important. I didn't just have my file property change delay things. I had sync buffer the changes. Okay. So when I synchronize, what should happen? When I press synchronize, what should happen here? Okay, easy, relatively easy. Okay, both of us go into defensive mode. Okay, I change the ticket price to 23.5. You change the number of attendees to 3. Okay, we are still 0 because we are multiplying both values. Okay. Now, when I press synchronize here, what should happen?
No, only you, yours.
My 23.5 goes here. Sorry? My 0 will also go? My 0 will overwrite his 3. But I didn't change 0. So no property was fired for that. Okay? No, actually, when I say real-time synchronized here, I didn't tell you the full semantics. It is, I will send things in real time, and I will also, let's see what the semantics are. I press synchronize, and the value goes to the server. Because this guy hasn't pressed real-time synchronize, actually, he won't get it.
At which point his 3 is going to go back to the server, and then you would have to press synchronize again.
That's why do you think I put the real-time synchronize button in? Okay, so he said it in fast forward. We went and said synchronize. The change went to the server. It hasn't gone to anybody else. Okay. So the semantics are that if I press real-time synchronize, if I'm, and previously what happened, when I pressed synchronize, it went, so at that point it went to everybody. That's okay. So it went to the server, and now he presses synchronize, and he gets my value, but I don't get his value, and I press synchronize now. Okay. So this is concurrent transactions. And we had to do all these times. Now what happened was that I changed it to 24.1. Right? And what do you guys think should happen now when we both change the same value?
Whoever changed it last
should win. Because maybe, we are looking at stock prices, and the latest stock price is the one that we should have. Anybody want to say the first one? That's what sync does.
Whoever tries to get the ticket first gets the ticket.
Gets the ticket.
Well, technically, then it depends on circumstance.
Depends on the answer, but I'm going to argue that it is safest to always do the earliest. Because what happened? I went and synchronized. My value went to the server. I haven't seen your value. I've gone. Now you went and synchronized. You get back my value because you're there. And you say, oh, he meant 24.0 and I meant 24.1. And now you are there and you can make a decision whether to go and override his value or accept his value. So at least you got to see his value. So that's what the default semantics are. Okay, so that's what you should have. I do synchronize. He's synchronized, he gets 24.1. And now he can go, later user gets to see earlier value and choose. And now he can go and press it back to 24.0 and say, I really want 24.0. Now he has seen the value. It's not a conflicting transaction. And he can get it down to 24.0. Okay, that's a default semantics. Sync was meant to allow you with all these different merge policies, which I told you earlier. And this is just what we decided was by default. Okay, so we have the model view. We have now, we're understanding what sync does. And sync supports disconnection, as we've seen. It also allows fine-grained merging, as we've seen. If I change one value, you change another value, we don't just go and overwrite the whole object. Okay, which is what we would get if we were doing a text file. And there's user control coupling. You can decide whether to synchronize incrementally or not incrementally. And you can also do access control and concurrency control. When I've taught this course many, many years ago, somebody built a whole access control system around sync with the vetoable listeners and so forth. I never put it into sync, okay, but that's something you can do. Okay, now let's go and talk about replication awareness. We saw that our model was completely replication unaware. It fired properties, it went and, it has serializable. It implements serializable, but that's useful for other reasons. But somewhere else, I had replication awareness. Okay, in my main program, I use a sync API to go and register the object, do all these things. So there was replication awareness. We're not getting something for free. Okay, and I'm not sure of what I mean here, but basically the replication is based on logical structure. Okay, and we're doing explicit binding. Okay, that's what I mean. Why do we have replication awareness? we're not saying, we could say that every object created by this program is replicated everywhere else. We could say that. And then maybe we could get rid of replication awareness completely. But we are saying you can replicate some objects and not some objects, which means there's a choice, which means you must exercise it, and hence replication awareness. And there are models. There are models where each process is kept consistent with another process. And so there's no replication awareness in the processes. And we just go and, you can imagine ways of doing that. And I've contributed to some of those ways. Okay, one is simply you go and just, there's operating systems. You can just take a guy's memory and replicate it on another computer. You can play back all the UI events. Okay, all kinds of interesting things can happen. Okay, but we are not doing that. That's why we have replication awareness. So but a model is collaboration and distribution unaware. Okay? And I told you there's a way to go and replicate this property or not replicate this property. Now, can you guys think of a reason why we really want the model to be replication aware, to make a useful application? That the model itself, the replicated object, should know. What could it know, by the way? What kind of awareness could you add it? Maybe that will give you a solution. Let's talk as implementers. What kind of information could you give it? And then why would it be useful? So right now, get ticket price could be invoked by it. It's all get ticket price is going to be invoked by somebody locally. But the set number of attendees could be invoked by it or could be invoked by the system. By a local guy or a remote guy. If a remote guy, it could be invoked by Bob's because of Bob's change or because of Cassie's change. Might it be useful for the client to know who's the caller in some circumstances? There was actually a design of RMI at Microsoft that I saw. Not at Microsoft. It was actually a Xerox company that got bought by Microsoft. It was done at Xerox, where every remote procedure call took as an argument the site that invoked it. Okay, so you could go and figure out who invoked it. And that's a useful thing, and that's why they put it in there. That was a company called Path Places. I've told you guys that there is this algorithm Google Docs uses for consistency. It was invented by a guy. I'm going to give a little history lesson here because all these things are coming to me which are relevant to you. Okay? So let me go back a long way. AFS got invented at CMU. AFS, do you guys know any inventor of AFS you personally met or known?
Is that a guy in Andrew?
So AFS, the guy who was managing it was a guy called Jim Morris, who became the head of CMU, okay, at one time. But somebody local, Don Smith. Okay, along with Don Smith worked a guy called David Nichols, okay, who was a PhD from CMU. He went to Xerox. He worked with a guy called Pavel Curtis. Together, they wrote a paper on operation transformation in a system called Jupyter in a 1995 WIST conference paper. That came up with an algorithm that Google Docs has used. They also created a company called Path Places, which was like WebEx. Okay, they basically allowed presentations to be done distributedly, and they allowed screen sharing. That got bought by Microsoft, and that became Live Meeting, okay, which is their product. So in fact, I was at Microsoft when this was happening, and so I got to see, in fact, some of the details of and Park Place RMI was that way. That Park Places RMI, which became Live Meeting RMI, was that the user, the identity of the person came with this thing. Okay, so we can use some collaboration awareness to override predefined. And here's an example why we might do this. Okay, let's say I just want to go and put in the event history a log. If you guys go to Google Docs, you'll see there's a little log of who did what change. Okay, and that might be very application specific. So I might have a little, and by the way, I put this in here because you guys will need this history when you guys do your synchronization. and I go and on the console I go and say, okay, it's set to 20.0 by this guy, set to 25.0 by so-and-so. So I want some kind of accountability. I mean, if you look at version control systems, they will tell you who changed what, right? So that is something you might want to have in the model. Okay? And so that's where you might need the identity. And the way I put it was, I think, a little cleaner. So what are the later other calls you see here? In the call, you can say, who's calling me? I don't have to go and change the argument. I can just say, who's calling me? Okay? I can tell if I am running as server or as client. If I'm running as server, maybe I don't want to go and put all this history. I don't want to augment this history. Okay, because this is just meant for the clients, perhaps. Every client can recreate this state, and this history is going to be serialized also. So the history will be, maybe this won't work as intended. Okay, but there is this call that can be used to decide whether you're the server or not. Okay, which is useful. So what am I saying here? I'm saying I'm not server and I'm not remote. Okay, so I'm adding the history only once. This is what I'm trying to say, which actually does make sense, because we don't want the same event to be added multiple times. So that's what I'm saying here. So in that case, you add this event. And I can also say it's loaded by so-and-so. I can say who loaded this particular object. So I can go and say get client ID. So you see that I'm making use of these features. Okay. So main point, awareness in the model is sometimes useful. And again, you want to make the easy case simple and the difficult cases possible. Okay. Local host name plus ID. So we can get all kinds of information about. So we might just want the ID. We might want the host name also. Okay, so you get all this information, whether I'm the server or not the server. Whether I'm remote or local. So depending on what kind of, you might want to just know whether I'm remote or local, or you might want to know exactly who called me. So you can get all this stuff. The system has it, why not give it to you? Okay. I'm not sure what the slide was about. Okay. So what do we have now? We have okay, so again, I guess in the previous slide I just said the read-only properties. When you fire, okay, what the previous slide was saying was that when you fire a change to read-only properties, sync doesn't care about it. That's all it was saying. Okay, and I think I've said that before, so I didn't know why I was saying it again. So how are read-only properties updated remotely? As I said, the other side will go and recompute the different values. Okay, so how can I suppress replication of heritable properties? Okay, so my read-only property values will be ignored. The heritable properties I must suppress. And here's an example that I want to, and this becomes more complicated also. So I want to have a little button saying I will attend or I will not attend. Okay. So I have, each one goes and says that. So this is something I don't want shared, right? Because you'll attend doesn't mean I should attend. So I want this to be a non-shared object. Okay, so how would I do that? I just have, so by the way, this program is wrong, and I want to give you the wrong solution before I motivate the right one. So right now what I'm doing is, I just go and say set number of attendees and get number of attendees plus 1. So I'll just keep counting the number of people who will attend. That is a shared object, shared value. And each person goes and says whether they will attend or not. So whenever a set will attend is called, this particular value is supposed to change. That's the goal. This program doesn't work, but you You try to imagine why, but intuitively it makes sense. Okay. So we could go and make we can go and not tell the infrastructure about the attend property, but neither is view. So we can use two different notification models or use API as we talked about earlier. But I can just go and say this property or this particular model, please never share. Okay. Which is what I talked about earlier. So this is the API I talked about. Okay. I guess I'm saying I'm not sure what I'm saying here. Well, I guess I'm saying you don't have to worry about mess around with property notification. That's what I'm trying to really say. Okay. Will this really work? Set number of attendees, get number of attendees plus 1. Imagine that two users are working in a disconnected mode.
Oh, no, it won't work. Yeah,
Huh?
it'll take its local before it's done with its transactional synchronization, so yeah, that'll mess it up.
So what should we do?
Is there a way that we can require some properties to be non-transactional?
So what? Yeah, we can do anything. We can change sync. We can do anything we want.
We could, instead of directly trying to change the number of attendees, like queue the increment or decrement.
So okay, so have a list, have a queue of the changes.
Wait, like that way when you say set will attend, it just adds something to the queue instead of trying to directly change the value, so that once it does its transactional update, the next time someone calls a get, it has that entered in the queue, processes whatever queue has been unprocessed before it displays its local value.
Okay, so we want to basically keep a history of changes.
Yeah, and then when you transactionally sync,
It'll just, that history will come here,
yeah.
my history will go there, and we'll compute a number of attendees based on the combined history. So not a single value, but based on multiple values. And suddenly, there are two solutions to this problem. One solution is we lock. Okay, we have a single number, and we lock. Okay, either you're changing it or I'm changing it. Or we have multiple values, and we don't lock. Okay? And way back, Jim Anderson, when he was doing either his thesis or his pre-tenure work, he came up with the idea of weight-free locking, weight-free synchronization. And his whole idea was, whatever value is going to, you take single values and you convert them into multiple values, one for each user, and suddenly you don't have to go and block. That was the basic intuitive understanding I have of his work of that. Okay? And he was getting bored with that work, and he's saying, where else can I apply this non-weighting kind of idea? And he heard from Kevin Giffey about real-time computing. He said, oh yeah, that's interesting. That's a place where people wouldn't want to wait. So let me start looking into applying this kind of theory there, and then he just forgotten about his distributed routes, and he's gone into real time. Okay.
Couldn't you get around that previous issue by having increment and decrement methods?
Well, I mean, but then it doesn't work when it's transaction.
It's just a number, right? Our increment is, again, test and set. Basically, we want test and set to be done atomically, kind of, So if I'm increment, that's what I'm doing, right? I'm incrementing. This is all increment.
Well, the problem is that you were reading it.
Well,
and your read was disconnected from your write.
well, it's like, but you're still stuck with, if you try and do an increment, and like say increment your local variable, and then you do a transaction, right? So the question then becomes like, how are you getting the value for your user when you're displaying it? Because if you're saying, oh, I've just incremented it by 1, but what if 3 other people have decremented in that time?
So let me put it this way. increment ultimately, when we say I++, it really is I equals I plus 1. The value has to be read, whether we say it or not. You know?
Yes, if
That's,
you're trying to store one value locally, you can't do it in transactions and ensure that everyone's going to have the same value when they sync.
so we just need the collection of values. Okay? So again, to show this in slow motion, so I go and say, I will attend, and I synchronize. And this guy says he'll attend, he synchronizes, and they both get 1, okay, because each one did not read the other person's value. Okay. Local number and single collaboration can have race condition, classic atomicity problem. Okay, so transactions will not be weight-free or allow merge disconnection. So does this work? Does not keep track of who is attending. Rather than having a queue, I'm just going to keep a table of who is attending. Okay, and because I need to know that, you know, I mean that gives me more information. So a memory slot per concurrent thread, rather than global slot in Anderson's work on A8 synchronization. I've never talked to Anderson about my simplification of his work, but I think it's correct. So what I'm going to have is a little table which is name and attendance. Okay? So am I attending this or not? And this is something that would be useful for people to have also. And when I go and say this, I just go through that list and I go and add up the values in that table. Okay? And now in my set will attend, we'll just go and put a value in that. Okay? This is enqueuing the value, essentially. And so now I can even show the table to the user, and you know, you've got them both. You know, basically you can do this. And by the way, in Object Editor, if you keep some internal data structure that you want replicated, but you don't want the user to see it, I tell you guys in the assignment, you can go and say @visible false, or you can set some attribute false. So you need to do that. You need to keep a history of all the commands that each user executes in your assignment, and you can go and make that particular property not visible by just saying, before the getter method of that, I explained that in the assignment, you just say @visible false. So that property will not be displayed, okay, if you don't want this to be displayed.
Now, in this table idea, what happens if a user, couldn't they theoretically now change the attendance for someone else that's not themselves?
Yeah. So in this particular design, you can. And in your design, you know, when you just stored one value. But this is where another student worked on an access control framework. They can make sure that only you can change that. But in fact, one of my students has also done a thesis on this topic, on fine-grained access control. And there are so many times I wanted this feature. Honestly, I want to sometimes record attendance of people. And I want to make sure that only the person, you can only, you know, edit your stuff. And today in Google Docs and other systems, you can't say this person has access rights to this particular cell. Okay? But we guys came up with an access control framework that was easy to specify and yet allowed these fine-grained specifications. And you want that in collaborative computing systems. Okay? And this table you might want anyway, right? You might want to just see who's attending rather than number of attendees. So the table idea is not a bad idea, but certainly controlling access to the table is something you want to say. You want to specify access control, like if I'm in a demo, please allow access to the software. When I'm not in demo, I mean, you want some very complicated expressions to be given for access control. And this is actually a relatively simple specification. So I'm just saying that's an access control problem. Okay? And this is the classic interleaving problem. When you guys study semaphores and everything, you know that, you know, if you have an increment, you basically, it says local temp equals number of attendees, number of attendees equals temp plus 1. Okay? And you can basically get into trouble because this variable is not shared. Okay? So this is just classic idea. Well. Okay, we are done. Okay, now let me just go and talk about applications. We were done with the theory. So what can Sync do? Sync can go and replicate objects with properties, objects with lists, and tables. These are the basic structures it replicates. Okay? How far do you think you can go with this? I mean, what are the variety of applications you can build using this? Can you think of some applications you couldn't build? with everything I've talked about, is there any application you can think of that you couldn't build that requires replication? In theory, there is. In theory, anything that cannot be decomposed into a sequence, a table, and a record. In theory, a stack. Okay, I don't know what exactly what kind of stack you want to share, but a stack doesn't follow any of these patterns. Okay? But in practice, let me just show you. And by the way, sync has in principle, by the way, patterns can be also programmer defined. Okay, so you can actually I've got infrastructure. But here's the first application that was built using sync, a drawing application. It was just a table that kept track of shapes and names of shapes. Okay, and that still exists, and it's a very nice application. That John Munson, who invented sync, created this application. And he took some existing application and made it collaborative. Okay, Munson. Here's a word processor. Okay, that somebody built in one of my class projects, and that was replicated. And just a hierarchical structure, hierarchical nested sequence of sequences of sequences. Okay, of text. Okay. Here's an outline editor. Okay, hierarchical outline with leaf objects. Another guy built it. Spreadsheet. Okay, before Google Docs was there, we had our collaborative replicated spreadsheet. And this was just a hash table of records, I guess. And it used an existing spreadsheet, and it just added. It just took an existing model and added things to it. So I'm just trying to give you the applications of this kind of stuff. Gosh, I know this name, but I forget the guy. Henry McEwen, he did a calendar application. Okay, hash tables use existing single user tool. This was Calendrino. His idea was mobile computing, that we'll all in the different places in the world go and enter our weather conditions, and they'll just get combined together. And this was at a time when people had these ideas. And today, I hear this tech news, and there's something called Waze. You guys have heard of Waze? Yeah. That's basically this idea, right? Everybody's adding to their view of what's happening in the world, and it's getting aggregated together. Okay. So you understand how sync works to some degree. I haven't told you everything about sync, okay, especially the synchronization and the consistency management. And I told you guys, look, as long as all objects have executed the same set of operations, they are consistent. Okay. And we'll talk later. I'm hoping the last assignment of yours will allow you to extend your current implementation and make it make sure that every data structure is the same state. Okay. There's obviously the issue of the sync, that maybe you want more documentation, you want other stuff from sync, but in terms of its design. By the way, did you guys need anything beyond what I talked about in class?
I think the only question I had that I didn't immediately available was how to make a button in Object Editor, but I hacked around that.
Okay, you could have just done it from command line if you wanted to. Yeah.
Fair enough.
And you could have built your own. Yeah, sure. And some of you somehow discovered that, how to do it by hidden trial.
I just whatever object editor put in, I was like, I found it.
So it found it. It found your button. It didn't give you a button, right? It gave you a menu item.
It gives you a menu item.
Yeah.
It also gives you buttons. If you want.
Well, the thing that I had trouble with is I reduced the visibility of my stuff as much as possible. And so when I first started running it, it was like going through a minefield, because all my stuff was only package visible or something.
Hang on, you took the command processor and you reduced the visibility of the methods of. You can't reduce the visibility of inherent methods.
No, for my stuff.
For your stuff.
Yeah. So
I should have.
I don't create two separate projects for server and client. I kind of just cheat and put it all in one, and then say to myself, all right, in the server, don't import anything from the client, and the client don't import anything from the server.
Yeah.
And the way
No, object editor, I told you nothing about. If you were surprised by that, it should have been in a pleasant way that, hey, I don't know how to create a button, rather than in an unpleasant way saying, hey, why doesn't he create a button for me?
Sync. it was nice having the source code for it. Like,
Did you have it?
Wait, what?
Yeah.
No, I didn't.
No,
I didn't
what
export
did I
it.
have?
You had
What?
code, you didn't have that.
Oh, I had it for object getter because a listenable vector.
You
Yeah.
didn't. You didn't have that either.
Whatever had a listenable vector, I had.
That was available.
Yeah.
Oh yes, I took the util package. I did give the source code.
Yeah, so that was awesome because a listenable vector, I was so happy to see, like, when I took the reference to sync out of my program, the listenable vector was still there because it was part of object editor, so I didn't have to go build an observable collection.
I didn't know we had that. Oh well.
But I required you guys to build your observable collection for the assignment, sync assignment, right?
Oh, good.
Yeah.
I did that then.
Yes.
I
Yes.
thought we just had to get it done.
No. In fact, I replied directly to you, a message to you in Piazza saying, you have to do your own collection. There's a record in Piazza. So, and listenable vector that's why I wanted you guys to build your own listenable vector, because I wanted you guys to go through your source code and trace the events there. And I didn't realize that I had given you the source code for your listenable vector, which would have been.
Oh.
So I did it more to help you guys, but still, that was required. Okay? Thank you for telling me.
Yeah, I mean, it's there, like, and
So.
I mean, is that going to hurt me, though?
Yes.
I mean, I understand the basic idea.
He has the sinking feeling. You didn't. He has to be rewarded for that.
I mean, but like, the observable collection wasn't. I didn't think it was that difficult. Like,
So do it yourself then.
I mean, I did when I thought it was going to be broken when sync wasn't there, but then I took it out.
Anyway, so but beyond that, I gave you enough. I mean, Asad tried something which didn't work, which was intuitively should have worked.
Oh, I haven't submitted the assignment yet, but when I'm creating my own sync mechanism, I actually did work around that in my sync mechanism.
Yeah, no, even in so what he tried to do was try to create two syncable objects within the same address space. So these objects would be kept consistent. And sync wasn't quite designed for that, but as Asad pointed out, how does a server know which process it came from? You just give it a name. But they both come from localhost. It doesn't have the process ID, so it's just relying on name. But the thing is that I took a lot of sync features and I put them as static methods.
So a lot of static variables get set, but they're supposed to reside within, not be static either one.
But there is, that static stuff was all added to make your life easy. Otherwise, you have to say new sync client, and you have to say client.synchronize.
Or
If you,
even then it doesn't work. I tried every single approach and it doesn't work.
well, just think about it. It has to work if the static state is not being changed.
I know, but even when you do it with the completely asymmetric,
No. Symmetric, asymmetric is another thing. There's just no sync. Just don't use sync. Sync is just something I added on top, which is a set of global.
sync.replicate.
So sync, you just don't have to use. You can't use sync.
Okay, so
You can't use sync.
How do you replicate?
You create a new object called the sync client. You give it the server, and then you say sync client.replicate. So
Or did we have to use the already existing sync server?
And that's exactly what I
for your
So my custom implementation of sync.
custom, please, custom.
Okay.
Custom. Don't use anything in sync.
Okay, that's what it said.
No, he couldn't get sync working also. He couldn't get even the first part working. And
The only thing that I would have liked to have more information on is how the events get passed up and down. So I had a little bit of confusion about that. I was able to work it out in the end, but
so, I thought
specifically from the listenable vector.
okay, so the event gets trapped, and it
We
gets,
haven't considered
but I talked about that. In general, a write method will announce an event. That event will be listened to by the sync client. It'll send it to the sync server. Sync server will process that event, call a method in its object, send it to the clients. The client will go and call a method. So just a client to event to method translation. Okay. And I didn't tell you all about sync because A, I've forgotten about it, and B, I don't. I think I know almost all of the code, but I didn't write the code. There were two other students who wrote the code, and I just kind of made it teachable. Okay.
So because of the nature of the assignment, I tried to stick with the methods and responses in the sync you gave us.
Yeah.
You know, basically just copy your command processor and drop it on the new sync.
That's what I wanted you guys to do.
That was the intention.
Yeah.
Okay.
Yeah, because I want you guys to understand how a sync-like system might work.
Right.
And you can always, you guys had already done, some of you guys had already done some of the things that sync did for you in your first 2 assignments. You guys were keeping history, but I wanted you guys to understand that if the application was following certain rules to allow things to be generalized, for this particular application, how might you go and take those general events and synchronize them? Because in general, you know, dealing with recursive hierarchical structures and keeping all of them consistent is not an easy task. Okay. So let's go and talk of the limitations. You know, so I showed you last time I did sync. I showed you a bunch of projects my students in previous classes had done, and in those classes, basically, they were more like seminar courses. I would say, okay, come up with a project, okay, and I don't have to give you an assignment. That's kind of easy from my point of view. By the way, anytime a teacher goes and says, you come up with a project, they're doing less work. When the professor has to come up with a project, you know, they're doing far more work to make sure that you learn. So I was doing less work in those days. And so they came up with very creative projects, and I showed you all the various projects you could do. So let's talk about what sync can't do. That's always the more interesting thing. So is there any kind of object, you know, can you use sync to implement Dropbox? What is Dropbox? It's just a table of tables of tables. What's a directory? It's just a table with, you know, and a file, you know. So in fact, the first application that was built using sync was literally a replicated file system. We could, I mean, this is far before Dropbox. We could replicate 2 file systems, and John Munson, the student, just built the hooks to the OS and kept these systems. Okay, so we saw it could do spreadsheets, everything. So what can't it do? Can it do a stack? Classic O example.
It can do lists.
It can do list
Tables.
and beans. Any composition of these 3, which is where the fun part is actually. Yeah.
Yeah,
So
why couldn't you
there's
just
a lot.
implement a syncable stack?
so without changing sync, or
Like without changing the sync, just have a list and restrict the other side. Yeah.
if your top level object is a stack, top level object is a stack with push, pop methods.
Right.
Sync, you can go and certainly go and say replicate, and all the variables will get, you know, copied over using serialization.
Right.
It'll come back. And now you went and said push.
Okay. And so I sort of add it to the front of my list. And
Okay, and what event do you fire? Okay. And so sync gets a vector add element, and what is the target of that? I mean, so the vector is what? Vector is some vector kept inside the stack?
Yeah.
Can sync see that sync even know that you have that vector? You can, you know, can it even know that you have a vector? Remember, stack is the classic ADT. I mean, you know, I don't know, did any of you not study stack as the first example of an object,
Yeah. For sure. But
What did you guys do? I'm just curious. My generation was always a stack. And what is the reason for making stack an ADT? Because inside, you could have a vector, array list, linked list, whatever, and the external world should not be able to see that. Okay? What does sync do? It looks at your API, looks at your public methods, sees push, pop. So I don't know what these are. The fact that you have a array list inside, unless it does reflection and it goes and finds the private fields, which you're not supposed to do, if it's just looking at the public interface, it doesn't even know you have a vector. So you can fire your events merrily away. Sync hasn't even registered itself as a listener of that. It doesn't even know it exists. Now, in principle, a stack is a limited form of a list in some sense, right? It's a restricted list. And I could build that into, I build that into object editor, by the way.
You're saying you can't restrict sync to
stack again?
Well, you can't do it because it doesn't know about because you don't have any public methods that directly reference the
List.
vector or the list inside. So the sync doesn't know about it, doesn't replicate it.
Because they're not
And-
properties.
Yeah, because it doesn't fit the bean.
Or bean or the vector.
Yeah,
Alright.
you've got
Or the list pattern.
You've got no hooks that sync can use to figure out what's going on. So it will happily replicate the list with the object when it gets serialized, but it will also happily ignore any event that comes in to reference it because it doesn't know what you're talking about.
Absolutely.
Okay.
But I could build that. I mean, stack is a general enough thing that I could build that into thing and have it go and say add vector listener in it. Okay, then it goes and says, then it can go and say, okay, you're a listener, you're a vector listener, fine. And then you can file add element methods and try to do, so I could build, basically there are patterns that it relies on. And there are kind of events it relies on and they don't fit this entirely. And in the case of object editor, object editor does reflection in its own way. Sync does reflection in its own way. In fact, object editor started doing reflection first. Then I went back to sync and I had a student go and put that kind of reflection into sync. So the first sync did not allow beans and properties and so forth. It had something called replicated record, replicated collection, replicated hash table. It had these types and you had to subclass of these types to create something replicated. And then what I did was I had a student go and build a layer on top, and what we essentially did was take your object, convert that into a replicated string, which you found out, or replicated vector collection, and then sync works with those objects, and we go and then, so that if things are slow, they're slow for many reasons, and we added this layer on top. Okay? So I could go and add the layer there, and that's, in principle, we could do it, in principle. Okay?
And your unconversion wasn't happening very well, because when I got it back, it was like, I gave it a string, but when I did a lookup, it gave me a replicated string. It didn't fall into the value set.
Yeah, I mean, that part was not meant for the strings. And it was meant for a listenable string. So there's something called a listenable string which fires events each time you add a character to it. And we use that to create these synchronous editors. So if you went and did a listenable string, it'll do correctly. And a string, it probably won't. It's something confusing. Because string is immutable. So it's a contradiction in terms, and I don't know, it should really give you an error at that point. Okay? Okay. So we could define a pattern based on vector, but now we are stuck with, and so this is the thing, that to allow any object to be replicated is an impossible task. Okay? If it follows certain patterns, then we can do a lot of interesting objects. Okay? But we can't replicate any object. That's sort of the principle here. At least using the sync philosophy of state replication. Okay? We'll talk about other replication schemes later, and we'll go more into depth into each of the subjects we've gone into before. But for now, this kind of work. Okay, how about a counter? Maybe that was your first ADT. What was your first ADT?
It was a stack.
Stack? Anybody? It was not a stack? Abstract data type?
Search there.
We did,
When you search
No, the very first,
circular queues,
as your first abstract data type, you guys learned it pretty late, object-oriented programming in that case. But most 101 students, who come to my 401 class, they haven't seen stacks, but they know about objects. So, they're told how to use class. They don't really learn encapsulation.
I think maybe their first abstract data type is dog, because you've got that's the canonical
dog.
example.
Really?
for
Dog
an
as
object is
an
like-
object?
it's
Bark?
like-
And
yeah, you have like a bark method that prints a string that's
No,
Yeah,
because they have a
the
speed
speed
method.
method.
and it contains
That's
like
the
properties,
says-
names, and
says
stuff like that.
Mark.
Yeah. It has like a name and a read. It's to like introduce the difference between classes and objects. Like an object is a particular dog, whereas a class is just the general definition of a dog.
Okay, I use cars for the same kind of analogy. Yeah.
We did vectors, then we said, okay, now we can use metrics, we can do stats, and then you can also do queues. Then they gave us an assignment of going to insert trees.
No, but that's okay. But you were doing it all in Java, right?
C++.
Okay. So you began with C like things and went to ++ later. Okay, that makes sense. Okay, counter. Simple example. Can sync replicate this counter? And way back, when we had the problem with attend, we said that, we can't have it as Boolean value because we can do race conditions. And Ben said, why not go and make it, don't have a set values, counter value, because that's where you're going to do trouble. I set it to 1, you set it to 1, we didn't know about each other's, and these sets together can't add up. So why not have a counter that has increment and decrement maybe also, and you just go and use this counter, and you somehow, when you sync, the increment operation should add up. So firstly, there's no set method here. And again, what are you announcing? So again, I'm just pointing out the limitations of the state-based
I
replication.
mean, you could maybe cheat where you say set counter and then it takes in an int, but it doesn't do anything with the int. It just behaves as an increment.
Yeah, but what event does it fire?
So it will fire.
But sync is very smart. If you go and fire the same event twice, it's not going to go and put a log of those.
Oh.
It's not, in fact, ideally, that's what you guys should have also done for your properties. When the same property is fired 10 times, you should just record the last value of the property, not all the changes. But I mean, that, I hinted to you that you can keep a log of everything, and that's okay. But I'm saying sync is not going to, it's going to do the compression. But that's interesting that if it did not do it, if it just went and played all the properties it had, then sync will be very easy, by the way. You don't have to keep state. I mean, sync keeps a whole copy of your object in memory, and it just goes and it figures out which parts have changed, and it just sends those changed parts to the server, and the latest value of those changed parts. Okay? So, but that shows you, again, a limitation of the state-based thing. Okay? So, there's a typo here. But we've ended up changing the counter to a table, and we add the Boolean value to a table, and we decided that, this table is anyway it's a more correct, it's a better data structure because we also know who can attend, who cannot attend. And so we essentially, just as you guys took your property changes and converted them into a vector of changes, just because it wasn't working for that also. Okay? Because you didn't want the latest value of the property, you wanted the history of the change list items added. So you guys sort of built it around and you said, oh, this is really a list. And I won't export the list object editor, but I'll export it to sync. So, okay.
So is it just fundamentally something you can't do because we try to fix the fact that sync won't do the increment, like we try to put an actual setter there, then we run into the same race condition we had with the attendance problem.
Yeah, and then we change that to a table.
Yeah. And you can't really change this one to a table unless you do something clever.
Change here, counter. You could have a list of all the values list of log of all the operations.
Well, yeah, that's what I was saying. So, the other thing you could do is just timestamp all of the operations, and then just whenever you're getting the value of the counter back, just pick whichever one's the most recent.
No, actually, much simpler. Every time an increment occurs, just add the increment operation to a vector. Very inefficient.
Oh,
Okay.
I see what you're doing. Okay.
And now, in the end, everybody has you just want a set of all operations, right? You would just increment
So
one.
whenever you do a get counter, you have to execute the entire.
Or every time you get the new element added to the list, you go and update the counter appropriately.
Right. Okay.
And you'll have a very long log.
But this one, you can just get list.size.
Yeah, that's with the table, right? Yeah.
No, get vector.size.
Yeah, that's
It only ever increments.
No, you can imagine saying, I'm saying you can imagine saying, I'm attending, not attending.
Yeah.
So you increment, decrement. Yeah, otherwise you can just keep a number.
Which I guess you could, once you processed all the things.
No, you can't keep the number, right? Because the number is what the get counter was, and the numbers, I added one, you added one, how do they compose? You have to sort of both have to go and say, I added a list, item, you added an item. So the size won't work even if you just did pure increments. Because then I change the size, you change the size, we both change it to 1. 1 and 1 will reconcile as 1. You have to have a vector where both of our actions are added up.
Wait, that's what he's saying. So you keep a log of all of them from everyone.
Yeah.
And then when you want the value of the counter,
You can get the size.
of the vector.
That's what you're saying.
But it doesn't work.
No, but what I'm saying is every time you get a new item, sorry?
I said, but it doesn't work if you have a decrement operation. I guess you could keep a separate log for decrement operations, size of it, and then whatever. But
Yeah, no, what I'm really saying is that every time you get an event that says element added, you just increment the counter or decrement the counter.
Yes.
So you don't have to look at the size in the getter, you just have a local variable that gets changed.
do it.
And if you could somehow flush out the elements you've seen, which becomes a tricky thing because the latecomer.
Right.
So I'm just saying, I'm showing you the limitations. Okay? You never understand a system. You don't understand your body or your car till it breaks. And then you say, oh, this is all the good stuff that's happening. You know?
Fair point.
So, okay. So the state versus event. Okay. Okay. So this idea of replicated objects. Do you think anybody would be foolish enough to implement it? Anybody else?
Tons of people have.
So who has?
Well, there are tons of replicated object systems. We've went over this of them before. Like a lot of games are replicated.
Okay, that's good. So there's a lot of replicated applications.
Oh, you mean like something in general?
Some abstraction.
Oh.
Does it make sense? I mean, would you, if people said, here's some money, okay, and build a replicated system, would you go and say, no, I'd rather go work for Sun and do whatever they tell me to? Or, not Sun, I guess, Oracle, no, whoever. Or would you say, you know what, I'll take a chance on this?
What do they want to replicate?
No, a replication
In
infrastructure.
general.
A
They want to
replication,
be able to replicate anything.
Do sync
no,
both up.
a replication infrastructure.
Okay.
Don't do a one-off application. Don't do what you did in the fourth part of your assignment. Build something more general. Is that something useful?
I mean, it would be useful. I don't know whether you could.
Make money out of it or not,
Yeah.
but you might imagine that it's useful. So,
So they want to be able to replicate just any arbitrary graph of
now, the word arbitrary, I want to be always, it's a very scary word.
Yeah.
You just saw sync and saw it couldn't do a few things, and in general, an object is a black box. In general, it's supposed to be a black box.
Right.
And the idea of displaying it in object editor or syncing in sync is cheating in some ways. If it's a black box, thou shalt make no assumptions. But in fact, it's not a black box. There is an interface. And if those interfaces follow certain conventions, which they're supposed to follow to make human beings understand each other's code. That's why bean conventions were created for a bean box and also for other people. Then you can go and do some things. Okay? But it's like one of those halting problem-like situations that in general, you're making assumptions, and those assumptions will break at some point. In general, ADTs means black box. And I started off with this user interface generation in a C and Mesa-like language world. And then I, came small. Then, I said, okay, how to go and do it in Smalltalk and how to do it in Java. So I had to, there was a big eureka moment for me when I figured out, hey, you know what? There are these bean conventions I could use. And there are these, that was a big revelation. And until today, I've seen people who sort of did user interface generation before me. They couldn't make that leap. So there's, in fact, only one system like Object Editor that will go and display, we use patterns to go and display objects. And I think it's a great idea, so we patented it.
You should look at the Wikipedia page for the naked objects. There's like a lot of things out there like that.
No, but just try to imagine, unless you assume certain patterns, you can't do that. Just believe me.
Yeah.
People talk a lot.
It
They
is the
use
whole
like
problem.
reflections.
Yeah, you can't. You just don't know what it is. So unless you have this way of having patterns and composing patterns, and there's no system like that as it turns out.
And you have to trust that you can't do something like what I was trying to do, where you cheat the pattern.
Yeah.
Because your assumptions are based on the idea that if someone's following your pattern, they're doing what the pattern is assuming they're doing.
Yeah.
Because, the problem just reduces to the halting problem because you can't analyze something enough and know for sure what it's going to do.
And in the case of ADTs, you don't even give them the code.
Exactly.
Even when I had the code, I can't tell if it halts. How can I figure out whether it's a stack or not? Right? So that is a fundamental problem. So arbitrary is a very dangerous word. And I'm just saying more than one application would you want to sync ever. And yeah.
Being mentioned as simply detriment searches, right?
Yes.
So what sync does it is just
And there's also vector conventions and table conventions. And I wish people would create vector and table conventions, which they haven't done. So both sync and object editor have had to go and invent those. I wish they were standard, but yeah.
So the viewers can actually just go in and see all the get methods through reflection, and then they just make a list of all the properties and just keep updating them.
Yeah, that's what both sync and object editor do. Yeah. And to some extent, in some ways, even the Beanbox does some things like this, but not quite. So I've got papers on this you guys can read.
Yeah. No, I mean that's one thing too is that that being committed having a no argument constructor. It's like if you do a bunch of stuff with like interfaces and stuff, and you're like building like you have like a factory or something, or you're using dependency injection and stuff, then if you try to replicate that, you have to look in and see like what the actual implementation is. That would be a challenge. If you're just trying to create like an arbitrary system.
Yeah, so arbitraries. Okay, but going back to sort of the assumptions made by Bean. So here's the following assumption made. The assumption is that if I go and do a set, I set a property to the value v, and I do a get method immediately after that on that same property, I should get back what I just set. And when we start cheating and not allow that to happen, that's when we get into trouble. And you guys told me about the Liskov substitution rule, right? So I had never heard of it as it turns out, though I know Barbara Liskov's work very well. So I'm going to taught that in my 401 class now. And I didn't have the patience to read what she had written. So I went and used my own example with this one. I said, look, if I take a rectangle and make that into a square, then, my set width will have to go in, my set width and height will have to make sure that these two values are always the same. So then this particular axiom will not be observed because you're cheating. You're not setting what the guy said. I give the example of a vertical line which has no width and a height. And if you go and set the width, you would go and ignore the value and say, no, I'll still keep the deep at 0, which means if you do get width after that, you won't get the same value. I told them, you know what, if it bothers you, don't do it, but just put an error message saying you should not go and do a set here. And that's what happens, by the way. Liskov substitution rule, from what I've understood, is broken in Java. You guys know of any famous class that does that?
I know of a particular class, but generics breaks it.
No, I'm just saying the Liskov substitution rule is broken. So have you guys have used the collection classes? And you can convert one collection into another collection. And the collection you get back typically is a read-only collection. It still implements the collection interface. So if you get it,
if you try and do a set on it or something like that,
it throws an exception.
Okay.
Yeah. So right there, it's broken, and it's a balance. We looked at all kinds of alternatives to solving this problem, and I said I give you no judgment on this. Liskov was a Turing Award winner, but it is broken in other places. Okay. So anyway, that's what gets broken. So would it be good to have this kind of stuff? What do you guys think? Would you risk it? So I went to Microsoft, and when I went there, lots of things were happening. And I told you about my friend who was doing this stuff with PowerPoint. So he was the vice president of the collaboration group at that point at Microsoft. So he's my high school friend and college friend. So I sort of knew everything that was happening in Microsoft at that point. And they acquired a company called Live Meeting. And I actually, since I was also an employee, I got to see all their stuff before they were acquired. And they had in their code. And I asked them later, can I talk about this stuff in class? Because it was all under non-disclosure that I saw this. And he said, yeah, it's just, we don't very much like what we did, but you can sure talk about it. So Live Meeting, you guys have heard of the Live Meeting product? It's the competition to placeware. So they have, Live Meeting is lots of things. But when you do a PowerPoint presentation, you get to, of course, share the PowerPoint, but you also get to share the status of other people. There's a lot of state that is shared among the various users. And that's all done through replicated booleans. I saw in their code replicated boolean, replicated int, and I said, oh wow, that's like replicated object. But they just had these particular the primitive values. Okay. Then while I was there, the second time I was there, so Live Meeting was acquired for about like $300 million. Okay, so if you want to really worry about, is there money in replicated types? Okay, and that's a product even right now. Then came Groove. How many of you heard of Groove? In what context? How?
It got installed with my live software suite.
It's still there? It's still around?
I don't know. I haven't used
It also
that in Windows.
No, but last time sorry?
It gets installed automatically with some I installed live method
And it comes through non-public.
So it's not dead?
No.
Oh, I love that. I loved Groove when I first saw it.
It's like an asynchronous chat / collaboration.
It's application of sync, if you want. Without the real-time collaboration. And you guys know who Groove. So you guys have heard of Lotus Notes?
Yes.
Yeah.
Do you know the relation between Lotus Notes and Groove? The inventor of Lotus Notes invented Groove. Guys, that's like saying that Steve Jobs went to Apple and came back to Apple, and there was a different Steve Jobs. So Microsoft acquired Groove, and we all wondered why they paid. So if they pay $200 million for a live meeting, they pay how much for this? You think? 20 million or 1 billion?
Let's say 20.
1 billion. And everybody thought that they were doing it for this guy. Sorry, his name I forget. And they thought he might be the next Bill Gates. Okay, so they thought they just want, this is a very smart guy. And I loved Groove, but I don't know but I love Google Wave also. Okay, I'm a collaboration guy. I love anything that has to do with collaboration, especially because I don't collaborate with other people. So the technology is used by not by me.
I mean, Groove was interesting. It was sort of like Google Wave, except it was asynchronous instead of.
Yeah. It's when we first saw the interface, it was just beautiful. I just loved it. Sorry.
Program that gives you control. Like what it does is essentially if I run it and someone can host it, and I can connect to them.
So peer-to-peer.
This screen pops up, and I get a second mouse and a second keyboard over there.
So it has also some of these things. So Google Docs, Groove, they're all in the same family, And basically, when I went to Microsoft, I wanted to do Google Docs. I told you guys. I don't know if I told you guys. And we couldn't do it just because PowerPoint and Word are just such messy pieces of code. You can't just put hooks in there. And that's why Google has gone and essentially rewritten that stuff, where the collaboration features are very rich, and the single user features are not as rich. And that's a trade-off we have to make in life today. Okay. But so they have these simple types. There are these tuples in Groove, which are like beans, okay, but they've got their own language to build things. And there are dynamic sequences both in Groove and live meeting, just specific types, like John Munson had, replicated collection. Not there's a pattern, you follow this pattern and it'll. Okay. And both GroupKit is another system in Groove have things like tables also. Okay. So these ideas are not, very sync specific. I mean, I think sync did it first, but these things have come later. And even today, I was listening to a podcast, and Dropbox has made a big announcement in the last 2 months, where it's going to offer an API rather than an application for these mobile developers. Yeah, so, iOS. Oh, so I told you guys about the Samsung versus Apple. Maybe you weren't there at that time. So I told you guys very early that, don't think sync is irrelevant. I actually helped Samsung against Apple because Apple was claiming some things that sync had done earlier. Okay, and suing Samsung for that. And so, but Apple, what it was claiming was like a little small piece about when synchronization should happen, actually, or whether you have control over when synchronization happens. They had a patent on whether you can be editing while synchronization is happening at the same time. That was their patent. Editing some other document while synchronization is happening. And all I said was, you just need a separate thread to do the synchronization. And apparently the old mobile computers would lock the whole computer while sync is happening. And they claimed that this was a big stride and they should patent it. So, I mean, I just couldn't believe it, I said, yeah, sure, you can do it. I'll give you an app here. Here's a thread that keeps doing sync. Here's a thread that does something else. Easy. So.
Well, they did try to patent around with rectangles. So
Yeah. Okay. So this is a relevant topic, and it's interesting when I was listening to the twit. This is a twit. This podcast I was listening to, and they were saying, the synchronization is really problem. And then another guy said, well, why is it a problem? I mean, Oracle has been doing it for ages. Yeah, but Oracle requires locks. Oh, if you don't have locks, that must be impossible. Does it work? And so there were these two guys talking to each other. And they said, oh, it's a very hard problem. People are working in all these companies. And actually, when Groove got acquired, I was working with live meeting guys. These are the guys who invented the algorithm that Google Docs uses for its synchronization. And we were very curious as to what Groove does, because we understand that algorithm. And we were very interested about how Groove does synchronization. And so they have a patent on that, but nobody could figure out what it was saying. And I doubt it works, because it was just too complicated. So, but anyway, yes, people are working, and it's a very hard problem. But you guys will at least implement the Jupyter algorithm that was invented by the inventors of live meeting. Okay, which is used by Google Docs. Okay, so none of these guys support programmer-defined types. Okay, so if you define your own type, they will not allow synchronization. And the reason why Sync can support them in the second version of Sync, because of the patterns. Okay, and you're restricted there. Okay, just to put this even in a broader context, there are three kinds of objects. There are by reference. Okay, where whenever you're site 2, you want to get the functionality of site 1's object, you just go and invoke methods on that site. That's your remote objects. Okay. Then there's serializable by value. Okay. You write here, you write another place, and they become out of sync. And then, of course, there are these replicated objects where you get 2 copies and a change in one. So this is a proxy, whereas this is a copy with a proxy that transfers changes. Okay. So you want to understand that this whole idea just goes back to the by value, by reference kind of parameter passing we saw in Pascal, except it makes it distributed. And when you pass it by value, you really need replication. Okay, or in-out. There was something called in-out in Ada, that you can have in parameter, out parameter, in-out, which basically means that after the method has been called, the values are copied back into the original site. And that's sort of like in-out parameter passing. Okay.